Welcome back.
Hello.
We're on day 2 of 4.3. We haven't gone anywhere. You probably haven't watched the video for a day or two, though. Well, some of them have been longer than that. But anyway, that's their fault.
Basically, we need to finish up 4.3 and put all these pieces together.
And before this gets too long, okay? This is where you're going to have to find exact values of all the trig functions using angles and reference triangles, and you're going to need to do it almost as well as you know your multiplication tables.
Like the back of your hand.
Yeah, or better than the multiplication tables.
Definitely.
Okay.
And there's two basic kinds of angles you're going to do this on. You're going to do it on quadrantal angles and non-quadrantal angles.
What the heck's a quadrantal?
You're going to tell them, so I hope you know. Let's get
started.
started.
All right, let's figure this out. Are we ready? A quadrantal angle is simply an angle whose standard position terminal side, an angle in standard position whose terminal side lands on an axis, okay? So, for instance, any axis or any point, I'm going to draw right here because I don't have enough room up there at the moment, but any angle whose terminal side lands us on one of these points, okay, on an axis. Now, what we're going to do to make this easier is we're going to use a unit circle. What's a unit circle?
It's a circle with a radius of 1.
So we basically have a circle here whose radius is 1. Big dot theorem. If you miss the point, make the dot bigger. Okay, but let's label these points real quick. This point right here would have been 1, 0 if my radius had been 1.
Yes.
And this point up here would have been 0, 1. And this point over here was negative 1, 0. And this point is 0, negative 1. Did I do all those right?
I agree.
Got to be careful when we get them all right, because in a unit circle, based on what we did last class period, we figured out that the sine of theta in a unit circle was simply the y-coordinate of the point.
Yes.
And the cosine of theta
was the x
value of the point. And the tangent was what?
It was y over x.
Because it was sine over cosine.
Yes.
But it's simply y over x. And we're going to use this circle to generate these points because we have x and y coordinates.
Okay.
So the x coordinate is going to be cosine, the y coordinate is going to be the sine, and the tangent is going to be the y divided by the x. So I'm going to get rid of the circle and I'll draw what I need as I need it. Okay, how about the sine of pi? Well, if we were to draw our angle, we start at 0 and we finish at pi. So our angle is here and we finish up at that point. Well, we pretend like our circle only has a radius of 1 and our point is at negative 1, 0.
Yes.
So how do we find the sine of pi?
Sine is y. The y of that coordinate is 0. Is the answer 0?
The answer is simply the y coordinate of that point, which is equal to 0.
That was easy.
That's as hard as it gets.
Okay.
Let's try the next one. Cosine of negative 360 degrees. Well, if this is 0 and I'm going to go negative, which direction do I go?
Down or clockwise.
Down, and if I go down 360 degrees, I end up back where I started.
Yes.
And what's the coordinate of that point on a unit circle?
1, 0.
1, 0. And which one of those coordinates was the cosine?
Cosine was x.
Cosine was x. So the cosine of negative 360 degrees is?
1.
1, and you're done.
Nice. Do we have a lot of these on the test?
Absolutely. Not, well, they get mixed in. That's what makes them hard.
Oh, okay.
Okay, cosecant of 3 pi over 2. Well, 3 pi over 2, this would be 0. This would be pi. So if we're breaking it into halves, that's 2 pi over 2, which makes this 1 pi over 2.
So it's at the bottom.
It's at the bottom. We went 1, 2, and then 3. So 3 pi over 2 lands me right here. I go all the way around to there. What are the coordinates of that point?
0, negative 1.
0, negative 1. And now I have a cosecant. Now, I know that sine is y, cosine is x, and tangent is y over x, but that's not cosecant. How's cosecant related to one of those?
Cosecant's the reciprocal of sine.
Okay, so cosecant is the reciprocal of sine. So the sine is the y value.
So the sine is negative 1.
So sine is negative 1. And what's the reciprocal of negative 1?
Negative 1.
So the answer is just negative 1.
Will that always happen?
As long as I'm flipping over negative 1. Let's find out this last one. I don't know if you've noticed, but we've ended up in different places every time.
That's convenient.
It's almost like somebody thought these problems through. Okay.
Oh, wait, I think that was me.
Oh, it couldn't have been me. All right, 0. And we're breaking it into half, so this is 2 pi over 2, but we're going in a negative direction. So how about negative 2 pi over 2, which would make this negative 1 pi over 2. 11 is going to take me a while to get to, so here's what I'm going to do. I'm just going to count by ones here. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Holy smokes, 11.
It feels like Sesame Street.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Just 11.
Okay.
Okay, we're at
That was
0,
embarrassing.
1.
This is at 0, 1. Okay, well, notice we ended up in different places every time. You could have probably figured this out without counting all the way around. All right, but 0, 1. Now, secant's not one of my little things up here at the beginning either.
No, it's reciprocal of cosine.
It's the reciprocal of cosine, and cosine is the x value. So my answer is the reciprocal of 0.
Is that 1 over 0?
What's this reciprocal of 0? Well, 0 is just 0 over, like, 1, right?
Yes.
So if I flip it over,
That's 1 over 0.
1 over 0. That's okay?
No, Mr. Lucky, you can't do that.
What happens when you divide by 0?
It's undefined.
Bad things happen. This is not work. This is undefined.
So my answer is undefined?
Yep.
Okay.
There is no such answer. Okay, and when we start getting into the graphs of the next chapter, well, this will become what amounts to a vertical asymptote on the secant function, but we'll get to that later. Okay?
Don't spoil the fun.
Oh, man.
Next slide.
All right, next one. So, don't forget that when you ever happen to get a 0 or you have to divide by 0, that's not going to happen. So you're not allowed to divide by 0. This will occur whenever you get tangent graphs or tangent, some tangent functions don't turn out to be defined.
Right.
If the, what was on the bottom of a tangent function was x, if the x happens to be 0, then you're going to have an undefined tangent function.
Okay.
And anytime we flip over sine and cosine or
When we're
even
dividing.
tangent, so how about the reciprocals?
Okay. So the only time we divide is on tangent and the reciprocals, so that has potential to be a 0.
Absolutely,
Or an undefined.
undefined. So anytime you get 0 on the bottom, that's bad news, okay?
Okay.
Not happy.
Not
All right.
happy. What kind of angles were those again?
Quadrantal.
Quadrantal.
Try saying that more than once.
Well, if you got to say quadrantal, I get to say non-quadrantal angles, which means we do not land
On an axis.
on an axis. That's all it means. Now, we need 3 pieces. I said we're going to put all these pieces together. The first thing we need to know is the sign. What tells us the sign? The quadrant of where we land. We talked about this last class. It was our little mnemonic, ASTC. All students take the classes, ants steal the cookies. Pick something. If it has dirty words,
Ants steal the cookies?
You like that one?
I like that one.
if it has dirty words, don't tell us because we don't want to know. Okay, the other thing that we need
Just tell me later.
We've been don't put it on video. We've been practicing reference angles, and we've been using them inside of reference triangles. So in case you missed it last class, this is just a little blip on what a reference triangle is, but it basically draws a perpendicular to the x-axis.
Do we ever go to the y-axis?
Never.
Never?
Always vertical.
Got
Up
it.
and down. Okay, the third thing we need, we haven't talked about in a while, but we need to know our 30, 60, 90 right triangle, and we need to know our 45, 45, 90 right triangle.
Weren't they supposed to memorize those?
They were. We told them about 700 times. Not only do you want to think of them as terms of 30, 60, 90, you might want to think of them in terms of
Pi over 6, pi over 3, pi over 2.
Yeah, we don't really care about that one because that'll be...
That's a
90.
quadrantal one.
That's a quadrantal. But pi 45 would be...
Pi over 4.
Okay. So those are the ones we really, really need to know. Pi over 4s, pi over 3s, and pi over 6s, because that's what our reference angle will be.
Are all our reference angles going to come out to be one of those basically 3 angles?
Yes, unless you did something wrong. All right, so let's take a look. Again, if you were in FST, you've seen this before. If you didn't take FST, it's a little new for you. But I'm going to start off real slow, and then we basically want to get really fast and really good at this. Okay, we need the cosecant of negative 60. Well, let's start with a picture. I'm a picture person. Negative 60 is going to be right about there. Negative 60. If you can't fit it on the picture, that's okay. Negative 60. Okay, so what we're going to do is we're going to take that angle, and we're going to create a perpendicular.
Back to the x-axis?
Back to the x-axis. And now we have a reference triangle. It's a 60-degree triangle. So what is the side across from the 60 degrees?
Square root of 3.
It is. And our shortest side was 1, and our hypotenuse was 2.
You must have memorized them.
I did memorize them. I know them. So there's our 30, 60, 90 right triangle. Okay, now we're ready to ask, what did the question ask for? They ask us for the cosecant. If I need the cosecant, that's the reciprocal of the
Sine.
sine. So let's find the sine of the 60 degrees first. Okay, now notice I'm going to kind of ignore the negative 60 for right now because I already have my triangle all set up. Okay, so what's the sine of 60 degrees? It was y over r.
Square root of 3 over 2.
Square root of 3 over 2. Now, think about your signs S-I-G-H and S.
Ants steal the cookies.
Thank you. I got stuck. I was talking and writing at the same time. Okay, we're in the cosine quadrant. which means that the sign will be
Negative.
negative. So the answer for the sine of negative 60 is negative, I should make that is negative root 3 over 2. But I need the cosecant.
So can you just flip over the answer?
You can just totally flip over the answer. Does it matter if the negative's on the bottom or the top?
Nope.
Not at all. But it matters if you don't put the negative. So make sure you double check your Ants Steal the Cookies, your All Students Take Classes, whatever you want to call it. Okay, let's try another one. We've got the cosine of 7 pi over 4. So again, I'm going to draw. So this is 0. This would be 4 pi over 4. This would be 8 pi over 4. So we're counting by 2's. Half of 4 would be 2 pi over 4.
So we're in quadrant 4 again.
6 pi over 4. Yes, we are. This time, what's our reference angle? So here is 7 pi over 4.
We go back to the x-axis.
We go back to the x-axis to make our right triangle.
So our reference angle is just 1 more pi over 4.
1 more pi over 4. Somewhere we should see that. I would like to see that in the first couple that you do until you get really good at it. Either listed off to the side or on a picture. Again, once you get really good at it, you don't have to write it down as much, okay? So make sure you're getting the right answers, and then you can start to skip steps, kind of like in algebra. All right, so 45, 45, 90. Pi over 4 is 45, so what are my sides?
1, 1, square root of 2.
1, 1, square root of 2, okay? So now we're ready to look at the question. We need the cosine, okay? The cosine is 7 pi over 4. So all students, take classes.
Calculus.
I'm in the C quadrant.
All right.
So my answer will be positive, and I need the cosine, which is x over r, so it's 1 over the square root of 2. I'm done. I don't have to flip anything over. Why?
Because I have cosine, not secant or cosecant.
Exactly. I don't have a reciprocal. Okay, so what I want you to do is pause your video, try the next 2 questions. When you are ready, hit play, and you'll see fast version of how to do this. If you have questions on any of the steps you're going to see, please ask us in class.
Press
right?
pause.
Pause. All right, so hopefully you got them right. Okay, again, you want to get really good at this. You don't have to have super detailed pictures when you get better at it, but the idea of the picture is to help you think of the quadrant. Because when you don't think of the quadrant, you don't get the right sign, S-I-G-N, and you get the answer, W-R-O-N-G.
Wrong.
All right, so we have all the pieces. We have one more puzzle Mr. Lecky's going to show us.
That's because she's too tired because she worked so hard.
I did.
All right.
I'll help you.
Puzzle. Here we go. You ready? We have the sine of, well, we want to find cosine and cotangent, but we got to work with this information. We're told that the sine is theta is 1/4, and the tangent of theta is less than 0.
What does less than 0 mean?
Negative.
Oh, negative.
So what we have in our quadrants, I'm going to steal this ant steal the cookies thing.
Do you like that one?
I like that one. All right. If sine is positive and tangent is negative, what quadrant must I be in?
You must be in the second quadrant.
The second quadrant where sine is positive and nothing else. Which means if I'm finding cosine and cotangent, these are both going to be negative answers, aren't they?
Yes, because you're not in the cosine or the tangent quadrants.
So I'm going to go ahead and I'm going to draw my triangle in the second quadrant, label my angle theta. Sine was opposite over hypotenuse, so I had opposite is 1, hypotenuse is 4. And what is that last side?
It's the square root of 15.
And how do we get that?
Because we're smart.
We're really smart.
No, we didn't.
SMRT, smart.
A squared plus B squared equals C squared.
Okay, Pythagorean theorem gets us there. If you need help with that, come talk to me later. All right, so how do I find the cosine of this angle?
Well, the cosine is x over r, or adjacent over hypotenuse, so square root of 15 over 4.
Square root of 15 over 4, but we're in the second quadrant, so the cosine happens to be?
Negative.
Negative. Then we also have to find the cotangent of the angle.
Wait a minute, that's it? We're done?
We're done.
Cool.
Well, not until we do cotangent.
Oh, but I mean, that's it. So we just need to figure out the quadrant, put the triangle in to find all 3 sides, and then figure out the ratio.
That's it. That's all
Okay.
there is to it.
Okay.
All right, cotangent of theta. Cotangent is?
The reciprocal of tangent, so it is adjacent over hypotenuse.
So that is square root of 15 over 1. You can write the 1 if you want to, but we're in quadrant 2. So we're going to have a negative cotangent as well.
That's it.
That's all there is to it. That's all there is to 4.3 day 2.
And that's all there is to the first half of chapter 4.
That's right. They're going to really need to make sure they know how to do some of this, though, soon.
Yes, because there's not a lot of partial credit. It's either right or wrong, and we want it all right.
All right.
Because they grade faster.
8 times 7 is 56. Doesn't matter if you get close. So you got to make sure you get this stuff correct.
All right, we'll see you in class.
All righty.